from TomTom, and thank you for coming after the break. I hope you had some coffee, some refreshing things. And for me, first time being here in Poznan, I have to say that the city is really beautiful with a lot of history, and curious to explore more. And I would like to start this before going into the details with a small story as well. It's not so old as like history of your city, but it's something that happened around 15 years ago, where three people from the sunny Silicon Valley traveled all the way to Amsterdam. And it was a rainy day, like the one that we had today. These people, they were super upset because they had good weather, they had to travel to Amsterdam. A representative from a small company went to pick them up at the airport and introduced them in the van, guiding through the office of the startup. And these three people, they kept staring at the small device in the van that was turn by turn driving and guiding the driver to the office. And this small device is this one. It's the TomTom device. It's a device that made us famous and is even shown in the you can see Computer History Museum, because it's something that changed the way that people live their life, changed the way that people drive. Not anymore a lot of maps, a lot of confusion, just follow the instructions and keep going on. And after 15 years, TomTom is presenting this. With some sound, I think, if it works. Hopla.
Meet Trillian, TomTom's very own self-driving test vehicle. Once a normal road car, Trillian was retrofitted into an intelligent testing vehicle designed to perfect the TomTom HD map. She sees through high-tech built-in sensors, 6 radars in the front and rear for obstacle detection, 8 LiDARs in the front, back and sides for 360-degree scanning, cameras for sign, traffic light, and lane recognition, and to top it off, GPS and powerful mobile antennas. All this gives Trillian a 360-degree view and the ability to locate herself. To process all the data coming from these sensors, Trillian needs a serious brain, which is neatly tucked away under her back seats, near her extra power and water cooling components in the trunk, making Trillian more than strong enough to operate on her own. Her actuators are controlled for precise steering, accelerating, and braking. An emergency override button and pedal make it easy for the safety operator to take control if needed. But Trillian's most complex part is her mind. Highly intelligent software controls her components, allowing her sensors to scan the environment, pick up on every possible object, and give them context within TomTom's precise HD map. So Trillian always knows exactly where she is, what's around, and how to plan her next move. Safely testing tomorrow's technology.
And this is not that we are going to build cars now, but we are going to develop technologies that we are already developing for contribute to a cleaner, a safer world free of emissions. And how we do this? We do by pointing on 3 main points. That is autonomous driving, connected vehicle, and smart mobility. But what's the recipe here? What's the main thing? The main thing that we are applying nowadays is data science. And data science is a bit of business terms, but I don't want to scare with business things. Business value here for us means creating better products that people will use more, so we can get more data and improve our decision when we develop this product. So the base of this is nothing else than data, right? We have huge amount of data that we have collected historically since many years until now, and I will show you which kind of data we are collecting, and we will process this data. We are processing this data with the best thing we can do today, artificial intelligence. Now people say that if it's in a presentation, it's called artificial intelligence. If it's in Python, it's called machine learning. So I will we will do machine learning. I will show a bit about this history of AI, which kind of machine learning we're applying, and which kind of innovative techniques we are also developing to start using AI on top of this data. So let's have a look a bit which are this type of data, right? Of course, we have location data through our devices. Location data is nothing else that lat long with the timestamps, 3 numbers. But we collect this with GPS, with GNSS, and we have so much of this data that every day we could go around the world 19,000 times. We have huge amount of this data that we have collected since here until now. And you can imagine here, this is a real representation of the traces that we have. But the world is changing. We cannot only state on these GPS traces. What we need to have is also community input from the people out there in the world telling us, oh, something changed in the world. Let us know, we will modify this. But for example, we will need to know also if a new road has been built, if a new bridge has been built. So in this way, we go to the government asking for this data, but we also do our own web scraping. We go on the internet, we find this information, we use this information to understand what is new in the world. And we have also a lot of satellite images. And you can imagine, if you combine satellite images and GPS, what you have is a map. And this is what we do. We do maps. We do representation on the world that can go in your phones, in your applications, but also into self-driving cars, right? We do other use of this data. One use, for example, is the traffic index. The traffic index is actually a ranking of which are the worst cities in the world with traffic, right? So we see here, the first one is Mumbai in 2018. We provide this information also for government. If you're wondering, oh, there is Poznan, yes, I checked yesterday. Poznan is number 33 in the world ranking. You can check actually the state of the traffic. You can check it this now live by scanning the QR code and see how Poznan is ranking now, which are all the statistics around Poznan and this time in time. And this is one way that we use the data. This is how we use data science to provide insights to cities, but also to every one of you when you drive in these traffic conditions. But you can imagine, right? If we want to give this information for a self-driving cars, the self-driving cars need to know a bit more. There is something else that we need to provide. And this is what we collect with our vehicle. If you see all these sensors around this car, are all the sensors that are inside Trillian now. There is this car that just have all these devices inside and can go and test our products and our what we do with our maps. And you see that we collect a lot of data. Panoramic images, 360 views of what is around the car. LiDAR, that is kind of radar that scans and checks for obstacles, but we have also accelerometer, gyroscopes. So we process all this data, and I will give you a bit of feeling how we are processing this data using machine learning. This is what we do. HD maps, meaning high definition maps that are accurate at centimeter level, because this is what the car needs to know. At centimeter level, what's happening in the surrounding. And this is, of course, given by sensors, but the car needs to also look forward. It needs to know the way forward. And that's why they need maps. They need maps that help them to say that after this, I need to reach that point through that path, right? And they need a lot of maintaining. And this is the automation. This is where we apply a lot of machine learning to maintain this map in an automatic way, because if not, all the people in the world couldn't do the job, right? So let's go a bit more in the nicest part of this, right? What is AI? What is machine learning? And we are here, the name of this conference is beautiful because it's positive technologies. It's something that could bring benefit to people. And most of the time, when they talk about AI or machine learning, are considered like black box, something that you use and you don't understand. And from now on, in the next slides, I want to give you a bit of feeling. What's the essence of machine learning? That seems difficult, but it's nothing difficult, right? It's a real high-level overview of what it means, machine learning, right? And machine learning, AI is nothing new. And AI was born during the 50s for having a cool name for founding a project in the US. But the real point, the real breakthrough happened during the 80s when computer scientists started developing algorithms capable to learn from data, a fine pattern out of the data. And after this, there was a period that a lot of algorithms that we are still using, and some are also in our devices, have been developed. But what happened in 2010 is that new algorithms came up, a bit more complex. And this is the trip that I want to do with you. From machine learning to deep learning, what's this evolution and why these deep learning algorithms are working so well nowadays, right? But before all, let me go a step back and say that what does it mean, machine learning? What's the difference of machine learning with software development, right? Software development, we are all developers, right? So when we want to solve a problem, we create an algorithm in our mind. An algorithm is a sequence of steps. We code this into a programming language, Python, C#, Java, and every time that we put input in the algorithms, we get the output. That is generally always the same, given the input, right? So, for example, if we want to recognize letters, we come up with a lot of rules, right? The A is 2 lines with something in the middle, the O is a circle, the Q is a circle with something on the side. Plenty of rules. The problem is that the world is difficult, right? This is the reality of the world. We are not even capable to read these things. And this is where machine learning helps us, because there are a set of machine learning algorithms that scientists have developed that we need just to use them. And these algorithms accept both input and output. So this is an A, and you give the label. This is a B, and you give the label, and so on. So you get to teach the machine to understand this association between what you give and what is out there. And this is very simple. We don't have to do anything else than give an example. Of course, we need to give good examples. We need to teach properly. And this is what is called supervised learning. And there are other forms of learning like unsupervised or semi-supervised. But from my experience, supervised learning is nowadays the things that works, the thing that you can really put in the problem. That's why we focus a lot on supervised learning. We explore other techniques like reinforcement learning, but we still notice there is something lacking there that can create good products, right? So when we learn this association, we create what is called a model of the world, a model of these things that we teach to the algorithm. And when we have a new input, there is something, an output that is called a prediction. And this is the big shift in machine learning, right? Because a prediction is not just looking into the future, but is an output with a probability always associated with it. So every time there is something coming out of the model, there will be always a probability associated with this output. This probability can be very high, 99%. It's still one chance that could be wrong, right? This is the main shift that we have to do when we talk about machine learning. Let's make a practical example, right? We want to distinguish banana versus all the other fruits. Machine understand number, so we need to give to them significant number that represent the problem, right? And we call these features. And if, for example, few seconds, which are 2 features that you can consider interesting to solve this problem? Think about it, few seconds, they are very easy, right? One, of course, the color, right? How yellow is, bananas are all yellow. Fruits can be all the other colors. And another one could be the shape, right? Banana, they have kind of oblong shape. The fruit generally, they have rounder shape. And this is the principle of machine learning. We collect a lot of this data. In one part, we put all the numbers of degree of yellows. In the other part, we put all the numbers, the degree of shapes. And we do nothing else than separate this. The algorithm create a separation that is the best separation possible between these 2 classes. Whatever is on top is not banana. Whatever is down is a banana. This is the essence of machine learning. It's not difficult at all, right? But the point, again, is that the world is a bit complicated. This is a particular situation that you can put a line. Most of the time, you cannot put simply one line, right? So it's difficult. What would you do in this case, for example? Have a small idea. Yeah, you can put several lines, right? It's still simple, still lines, but there is something beautiful in this concept. And this, actually, one line here is performing very bad. If you see that one, so a lot of blue points are also on the other side. This line as well is the combination of this line that make powerful the model, right? You put all the line together and the combination of this line work perfectly. And this basically has kind of theoretical explanation, right? Imagine that you are using 25 of this line and each line has an error of 35%. 35% means that 1 over 3 times, this is wrong. It's very annoying. It's really bad, right? Basically, and this is the only formula that I have in my presentation, so don't worry. If we combine 25 of them, the final error rate will be only 6%. So the combination of simple model working together give us the capability of having accurate results at once, right? And if you have one of these previous, like 2 or 3 years old digital camera, this concept is the one that was working in your digital camera, the face recognition, working on another boost classifier that apply this concept. It has been very powerful. It has been the first time that people have been capable to put machine learning into devices, right? Things have changed. What you see now, we have put all this in parallel, right? But nobody tell us we cannot do this one after other, right? So we have the parallel thing, all combining their results. We have another level where we combine other classifier on top of that. And this was a limitation until 2010, because we couldn't put more than 2 levels, right? Let me add something. This straight line also represents the simple model of our neuron. This model that is called the perceptron and comes from the 40s is nothing else than the simple model of how one neuron in our brain works. And in our brain, we have billion on that. Now you can imagine, right? We have a linear classifier. We have many of them. Wow, we can build the brain. Interesting. So actually, it takes 30 years to scientists to figure out this, right? This is a paper from the 70s from some Japanese scientists that they prove that if we combine a lot of this perceptron in a parallel way and stacked one after other, this system starts assembling the human visual system. It does the same things that the human eyes does, can recognize the same things that the human eyes can do. And we arrived to 2010, as I said, we have now systems, and this is pretty old, this is 2015, a system with 156 layers, a neural network of 156 layers that basically is recognizing people better than persons. They're better than us in understanding who is a person, right? And why we have achieved these things? Because we started having graphical processing units, parallel units that can compute very fast and in parallel all the training of these models, and we start having a lot of data. This combination of the two make possible the generation of this breakthrough that is happening now, that is called deep learning, that is changing the way that we are living our day. Every one of us, there is a statistic that say that we are using at least 5 deep learning systems every day, and we are not even aware of it, right? So imagine something. You have 2 of this network, right? One, smart, try to generate fake images, right? Fake images of whatever. Imagine it. This network is just trying to create images. There is another one, and this is called actually the generator. You can think another one that say, I need to understand if this image is fake or not. And this is called the discriminator. Let these 2 networks play each other for a long time. This is what is called generative adversarial network, and these are becoming really famous nowadays for this reason. They are able to create faces of people, and these people don't exist. If you scan the QR code, you go to this web page, you will have a face of a person that does exist in the real world. And every time is a new face. And this is creating a lot of worries. We have videos of Obama saying things that he never said. We have politicians super worried about this topic because you put the content of this online, it could be a real damage for the person, right? And this is why this generative adversarial network that has been declared the most brilliant idea in AI in the last 10 years is becoming really famous. Yeah, but for us, these guns, they were beautiful. When we understood what gun could do for us, said that, wow, we don't need to send cars anymore. Can you understand why? So, if we have images, right? We have our cars driving in the world, right? But we cannot send the car driving when it's raining. When you can send the car driving when it's full of traffic, when it's super sunny, right? So when we have these images, we can apply these techniques to augment our data set for free. Right, this is beautiful. And basically you can see here, this is something we are still working on actively, and this is a bit of sketch. We didn't publish yet, we are trying to publish this properly. But the idea is the same, right? You have pictures, you have all the pictures. With these techniques, you can start doing all the possible weather condition applied to the same picture through all out the world, all the different traffic conditions. This is something that will help us enormously, right? And this is something that it gives us the opportunity to increase our databases effortless. Not really effortless because we have people working on it, but at least we don't have to send cars every time that they need new data. We can generate automatically all this new data. And that's the way that we use generative data networks that are getting a really bad name nowadays into something that is positive, into something that is good for us and could help us and other people to have some real benefit, right? And there is also some other things that we can do with this generative adversarial network, right? One important thing for self-driving cars are lane detectors, right? If you have self-driving cars, the self-driving cars need to go straight, right? Inside the lane. And basically, these lanes are accurate at centimeter level, right? You cannot say that, we need 1 meter, really, really accurate. The problem is that we have so many of these lanes. We have, in the world, in general, 30 classes of lanes. Dashed lane, continuous lane, parallel lane, yellow lane. We had to train a lot. What we have created using generative adversarial network is a system that, given this adversarial training, is capable to make the classification, the segmentation of this lane accurate as humans, and sometimes even better than humans. You can see that some humans, they can have some mistakes here. The adversarial network is capable to detect this in such a precise way that, humans are not needed anymore. And actually, what you can try this. You can see the paper here. You can download the paper. Part of the code is available. You can use this actually to do your own work. You do your own segmentation because the framework is general enough and even has proved better than normal convolutional neural network that could give us precise information about what happens in the world, right? Because at the end, what we want to have is something like this, and something that on the roads, cars are recognizable, lanes are recognizable, you cannot see here, but all the street signs are recognizable as well, right? It's something you want to know all the things that happen in the world because the self-driving cars needs to know these things, right? And okay, also in view of time, I want to just show quickly these other things that we are working on, because self-driving cars, okay, the car go by itself, but personally, I like driving as well, right? Especially I like driving when we have a panoramic road or something nice that we can enjoy, right? And we have this, what is called road trip. That is a community of people that upload their own routes, panoramic route, historical routes, but we have a problem also here, right? We have a problem because when people upload pictures about this route, we have other things that they are not really routes. So we need automatic system here to understand what is a good image, what is a nice image, what is a nice panoramic image, instead of having, a selfie. Guy is nice, but this is not what we are looking for, right? So this is also where we are applying deep learning to try to understand if what we upload, the content of the community that is around these road trips, but in general the TomTom community, is something nice that can still be shown. And there is something else that when I talk with people, say that, okay, but how you do this? How you keep all your people, all your data scientists connected to each other, start talking, because of course you can imagine this is a team effort, but worldwide. And what I want to show you is how we live our life as data scientists in TomTom, and these are images from our last data summit that we have in Amsterdam. Which is... So also if your time, because I want to allow you to ask some question. What I want to say is that you don't have to necessarily come to work with us if you want to welcome, but you can try most of our technology on the developer portal. So we are offering our maps, our traffic information, our routing information for developers to use in their applications. And you have an amount of free calls on a daily basis that you can use, and this is the way that we also want to allow people to contribute to our vision of a safer, autonomous, and cleaner world. Thank you very much for your attention.